Okay, in this video we're going to take a quick look, or at least a look at the first part of section 12.3, which is geometric sequences. We're going to do a few problems. I'll assign a few problems for homework, and then we'll finish this section up when I see you again on Wednesday. Okay, so the first question says, find the nth term formula for the sequence 3, 6, 12, 24. You're assuming that a sub 0 is 3. So that formula may look like a sub n is equal to 3 times the multiplier for each of these is 2, so times 2 raised to the n. And this looks very much like an exponential model. So we're going to take a look at 2a, and then 2b and c will be homework. So just like we did in an arithmetic sequence, when we want to find the common difference in the arithmetic sequence, we take n plus 1 and subtract, or n minus 1 and then subtract n. This time we want to show the common ratio. We want to show the ratio, and we're going to do that by taking a sub n plus 1 divided by a sub n. So for this formula, negative 2 to the n, in the numerator I have negative 2 to the n plus 1 over negative 2 to the n. That's going to become negative 2 to the n times 2 to the 1 over negative 2 to the n. That's going to give me just a negative 2 because they will cancel. So my common ratio, r, is equal to negative 2. So my first term is a sub 0 is equal to 1. When n is equal to 0, a sub 0 is equal to 1. A sub 1, when n is equal to 1, is equal to negative 2. And a sub 2, when n is equal to 2, will be 4. Okay, so 2b and 2c are homework for you to work on for Wednesday. Number 3, in a geometric sequence, we will call a common ratio between terms r. What do we call r in an exponential function? We call it the growth or decay factor. The recursive formula for a geometric sequence with initial term a sub 0 and common ratio r, where a sub 0 is that initial term, is the formula a sub n is equal to a sub n minus 1 times that common ratio r. The nth term formula will be a sub n is equal to a sub 0 times r raised to the n, where n is the term, not the term, n is the number for a. I have to be careful of that, because if I say a sub 100, then I'm going to use 100, but we would want to recognize that's the 101st term of that sequence. Okay, so number 4, in a geometric sequence where a sub 0 is 1024, r is 1/2, we want to write a recursive formula for that sequence. So a sub 0 is equal to 1024. So a sub n is equal to a sub n minus 1 times 1/2. Okay, that's the recursive formula which calls the previous term. In B, we want an nth term formula for the sequence. So now I will have a sub n is equal to a sub 0 r to the n. So a sub n is equal to 1024 times 1/2 raised to the n. So finding a sub 8, a sub 8 is equal to 1024 times 1/2 raised to the 8th. And that's going to give us 4. Okay, next one we're going to take a look at is, let's see, number 6. We're going to take a look at number 6. It says find the 7th term of the sequence 1, 1/2, 1/4, 1/8. So when you're looking at this, you have to first find r. So r is going to be equal to 1/4 divided by 1/2. You can pick any two consecutive terms. You'll multiply both by that reciprocal. So you're going to get 2/4, which is 1/2. So r is equal to 1/2. And you might have seen that. I just wanted to make sure you could recognize it when it's not quite as obvious. So now I want to find the 7th term. The 7th term, remember, is a sub 6, because it's the 7th term. That's equal to 1, a sub 0, times 1/2 raised to the 6th, or 1/64. Okay, next we're going to take a look at is number 8. Okay. Looking at number 8, we are asked to find geometric means that are missing. It says find the 3 geometric means between 256 and find all possible answers. So when we look at this, I know my a sub 0 is 1. My a sub 5 equals 256. So I have 1, and then I'm looking for those 3 geometric means equals 256. So if I look at my formula, a sub n is equal to a sub 0 r to the n. I know 256 times my a sub 0, which is 1. I'm looking for r, and that is the 4th term. Okay. So I can solve this. I have that r then becomes equal to plus or minus 4. So I can have 2 possible choices here. When I substitute that back in, I'm going to get 1. I'll get 4. 16 and 64, or I will have 1 minus 4, 16 minus 64, and 256. Okay, so when you're looking for those geometric means, you have to find your common ratio, then take your common ratio, multiply it by the previous term to get the next term. The last one we're going to take a look at is number 10. Number 10 is similar to a problem we saw with the arithmetic mean. This time, we're looking to find a value of x so that x plus 2, and x plus 3 are consecutive terms of a geometric sequence. So if they are, then consecutive terms have the same common ratio. So we want to take a look at an equation involving those consecutive terms. So x plus 2 divided by x is equal to x plus 3 divided by x plus 2. So the common ratio between the second and first term and the common ratio between the third and second term should be the same. So here I will get x squared plus 4x plus 4. Here I will get x squared plus 3x. When I solve this, this will leave me with x is equal to negative 4. So now, when I look at this, x is equal to negative 4, x plus 2 is equal to negative 2, and x plus 3 is equal to negative 1. Okay, so that is all the problems we're going to look at in this video. So the homework assignment is going to be that 2, B, and C, number 5, number 9. Actually, I have enough time. I'm going to go ahead and do number 11 so I can assign a few more homework problems. 11 will be the last one. Number 11, we did problems similar to this with the arithmetic mean. Now we're going to look at them for this geometric mean. So in number 11, it says find R. First term, a sub 2 is 7. The fourth term, a sub 4, is 1575. And we want to find that common ratio R. So we know that we have, 1575 is equal to the, let's see, I think I'll write that one a little differently. Okay. A sub 4 is equal to a sub 2 times r to the second power. Okay, the difference between those two terms is 2, so that's going to be my n. That gives me 1575 is equal to 7r squared. Solve that for r, I get 225 is equal to r squared. So r is equal to plus or minus 15. Then you're asked to find a sub 0. We know that a sub 4 is equal to a sub 0 times r to the fourth. So 1575 is equal to a sub 0 plus or minus 15 to the fourth. When I solve that, a sub 0 is equal to 7 over 225. 11C asks us to write a recursive formula for the sequence. We start with defining a sub 0 as 7 over 225, and then write the recursive formula. A sub n is equal to 15 times a sub n minus 1, or, because there's two values for r, minus 15 a sub n minus 1. And finally, write an nth term formula for the sequence. A sub n is equal to a sub 0 times r to the n. So this becomes a sub n is equal to a sub 0, 7 over 225 times r plus or minus 15 to the n. Okay, so that's all the problems we're going to do on this video. So I'll add to the homework assignment problems 12 and 13. So I'll read the total homework problems to you now. 2B, 2C, 5, 9, 12, 13. I would like you to try 14 and 15. You don't have to spend a great deal of time, but just try and think about how you would come up with the solutions for those two problems. We will finish the note packet 12-3 in class on Wednesday and most likely have a problem set and prepare for that chapter test for the following week when we meet. Okay, have a nice weekend. I will see you Wednesday.